Thanks for having me. To start off, I'm going to talk about forecasting at scale and time series more generally. My name is David, and the next 20 minutes or so, I'll address our approach to automated forecasting of time series. Quick overview of what's going to happen. First, I'll briefly introduce Avantum Consult, or our data science team. Then I'll address what a time series is and why forecasting is relevant for decision makers. And to finish, I'll give you an idea on how we at Avantum approach the topic. All right, who are we? We are part of a German consulting agency, Avantum, which offers data-related solutions focusing on German-speaking countries. Currently, our team consists of roughly 12 people with diverse background and experiences. This guy over here, by the way, is me, 30 years of age with a background in econometrics. All right, so what is our mission then? Basically, we strive to convert data to business value, and to us that entails an end-to-end approach to data science solutions, as well as adapting to the respective IT infrastructure put in front of us by our clients. Now that you sort of have an idea of what we do, let me get to the core content of this presentation, time series analysis, forecasting. To kick things off, an often misquoted statement on predictions and more generally forecasting. It's difficult to make predictions, especially about the future. So pretty concise, right to the heart of the matter. Forecasting can be a bit of a hassle. Over the next couple of slides, we've summarized why forecasting is still worthwhile and what factors might make forecasting difficult. So why do we even bother with forecasting? Put simply, being able to forecast time series accurately provides you with a secure foundation when it comes to planning and decision making. Typical use cases range from all sorts of fields, from manufacturing to finance, healthcare. Basically, wherever you have a time series in front of you that is of importance to your business, forecasting becomes of interest to bolster your planning and decision-making capabilities. All right, so we know it's important to be able to forecast a time series, but what is a time series then anyways? I found this definition on the website of the OECD, which says that a time series is a set of regular time-ordered observations of a given quantitative characteristic. Or to put it a bit more technically, stochastic sequence, which might be affected by deterministic terms, t for time, and omega for events of the underlying sample space. So with that definition, how would we then go about forecasting such a sequence? Well, in a nutshell, what we are trying to do is figuring out an approximation of the underlying functional form that best captures the deterministic parts of the function or the definition I just showed. Having figured out this approximation, noted here as y hat, we can put this approximation to use and get actual forecasts for the underlying sequence. Respecting the fact that we will never get 100% accurate approximation, we add this residual term and derive this identity, which says that the actual value of a series in a future period can be described as its approximation plus whatever we were not able to capture. This residual term becomes important later on in the presentation, so keep that one in mind. So let's shift gears a little and look at a more descriptive, less abstract definition of a time series. Here we can see profit in thousands of euros plotted against periods, let's say days. And as started earlier, we can decompose this time series into its deterministic and stochastic parts. Furthermore, assuming that no exogenous variable plays a factor in this time series, we can describe the process as being influenced by time only, which is why we can decompose it into a trend, given here in red, and a seasonal term given here in green. The stochasticity of the process, on the other hand, is due to the error term given in purple. And if we were to add up these three terms over here, or representations rather, we would end up at this time series in blue. However, things are not always as neat and simple when dealing with a time series, and a couple of issues can arise. For one, the series might display outliers, here given in this red plot, unusually high or low values that would dilute our forecast accuracy when left unchecked. Furthermore, we might happen to find some structural break in the series, so that we would actually have to fit two models to the series, since the structural break effectively would mean that we find two regimes in one series, here given in green. Or another possibility of why we have to deal with problems in a time series is that it might be plainly irregular. Think intermittent demand for some grocery item, for instance. So things are not always that neat. They can go wrong. We need to keep that in mind. With that general idea of what a time series is, why it's important to be able to forecast the same, how would we now actually go on about forecasting a time series? Starting off with the data provided to us, one first separate this given data into what is called a train set, used to figure out this functional approximation y hat, and a test set to see if that functional approximation is any good. Now, using the discrepancy between the actual values here in blue and orange for the test set, we can then evaluate if our forecasts will be accurate or not. But since a computer is not really that good at evaluating graphical fits, we need some sort of KPI, some sort of metric to evaluate if the fit's bad or good. And using this difference, we can make use of metrics to actually evaluate if our approximation is of good quality or bad quality, basically. So with that in mind, I would now come to how we at Avantum would actually approach this forecasting problem of how we might be of use if a customer wants us to provide forecasts. We reckon that automated forecasting is the best option for most business problems, simply due to the fact that, for one, there is no one model fits all solution, and as such, having to fit tens or hundreds of models for a myriad of products or time series would just take you forever. So automating the process is reasonable. Furthermore, the potential issues that every time series displays, outliers, breaks, and whatnot, these need to be checked for every time series, and as such, this is a repetitive standard task, and automating the same checking for these problems and removing them is reasonable as well. So, okay, got it. But how would I, as a client, actually make use of this automated solution then? And here's our answer to that. We developed a forecasting app that allows the user to upload data as well as key variables, such as what variable you want to get forecasted and how far into the future you would like to receive your forecast. Subsequently, the data is processed and fitted automatically using some 40+ algorithms, ranging from simple linear regression or time series specific algorithms such as seasonal ARIMA to more advanced methods such as light GBM or deep learning models. Sorry. Afterwards, after the process has been fitted, you receive your demanded forecast. The service itself can be accessed by an API and therefore utilized from inside Cloud Packer for Data or incorporated on-prem. As such, we are flexible in terms of whatever IT infrastructure we might find put in front of us and can truly deliver an end-to-end integration. With that being said, let me give you a quick demo of a typical scenario of how one might go about using the API, plugging in some values, receiving predictions, and making use of those for decision-making capabilities. For this purpose, I fitted a model beforehand using our solution. Depending on the size of the data, this takes roughly 10 to 20 minutes. Which is why I fitted the model prior to this talk. So I've spun up this little radio app. And over here, you can see what variables actually go into the model. Some of these are derived automatically, like year, for instance, or calendar week. But I've listed them anyways to give you an idea what is actually influencing results. If you now enter a date like such, default date over here, and send the request, you receive the underlying best model, in this case, CatBoost, random forest-based algorithm, proved to be the best model for the given series. You also receive your forecast, 7,000 roughly in this example, and your test metric. For this case, we've used MAPE, which translates to, for test data, we are off by 4% on average. You also receive some plots, which are really not that great if you not zoom in, but what we have displayed here is the underlying series, sales in this instance, including the predicted series for the test set. And if you zoom in on the test set, you see that these predictions are pretty spot on, maybe due to the series being not that complex, or just because one of the algorithms really did fit well to the problem at hand. Let me zoom out a little. So we are at 7,000 over here, and now you might be interested in, okay, what happens if I change around some variable? How would that affect results? And for this purpose, we can, for instance, change the number of school holidays prior to our given date. And if we were to adjust it like such, we see how that would influence our prediction. So not really saying a lot about actual influence in a sense of causality, but giving you a sort of measure of what variable might be of importance. Keep in mind that this example does not trigger our API directly, but showcases how one might use the model on-prem, for example. All right, so that's what I wanted to show you. Let me finish off the talk same way I started it, sort of hiding behind quotes. Here's another one that I came across, this time getting biblical with Isaiah 41:23. Maybe a tad melodramatic, but cool nonetheless. Tell us what the future holds, so we may know that you're God. With that, thank you for your interest, and I'm happy to address your questions if you have any in the remaining couple of minutes allotted to me.
Well, thank you, David. So we have a little time. Any questions from the audience? Okay, I got 3 questions. So how much time does your AutoML solution take?
So depending on data size, as I stated before, we are roughly taking 10 to 20 minutes for fitting purposes, but inference, on the other hand, is basically a matter of seconds. So maybe you would go on about training the model nightly or weekly, and then using it for an inference straight away.
Okay, yeah, which makes sense, and you don't have to retrain like every day anyway. So yeah. Do you plan on adding new features, and if so, which kind of feature do you plan to add?
So what we have been talking about is integrating not only mean forecasts, but also variance forecasts. So adding confidence intervals to our predictions for one. And another point that we would like to incorporate is offering multivariate algorithms to forecast. So far, we only use univariate algorithms to forecast, albeit allowing for exogenous information, but something like vector autoregression, we do not provide an option to use these. So that is something that we would like to focus on in the future.
Okay. That makes sense. So can you already now incorporate multiple data sources, like external data, like maybe weather data, and directly into your analysis to make that even more pertinent?
Yeah. So exogenous factors like I don't know, weather data or stock prices, for instance, these are able to be added to the algorithm. However, you need to be careful, of course, with exogenous information. Would be best to rely on predetermined information and not information that you would have to forecast yourself to use as a other regressor in your estimation problem.
Yeah, so you define them as features, right?
Yeah.
Yeah. Okay. Okay, that's really cool. Anyone else has questions or comments? Oh, there's one from Erdogan. In the demo, I think you increase the number of holiday days by but the sales dropped. Any explanation?
So what might be an explanation for that? Let me jump back to the Gradio app. Sorry, not this one.
You got it, Erdogan.
Where is it? There it is. So I reduced or increased rather, I think, the number of school holidays in the last 7 days. And our prediction dropped from 7,000, I think, to 6,900. If you think about it, maybe at the beginning of vacation, people have money available to them that they would like to spend as soon as possible. And since we now changed the number of days since the last school holidays to 7, making this vacation or whatever start earlier, people might have already spent all their savings. So that is why one might think that the predicted score is actually lower when increasing the number of school holidays 7 days prior to today.
Yeah, so Erdogan is also suggesting maybe are still closed when the schools are closed, or is that
possibly? But keep in mind that the series is only for presentation purposes, and as such, yeah, take it with a grain of salt.
And one great comment also from Erdogan is, is there a way to see explainability there? You know, there's those big things about how to explain AI, and can you show it already? Is it part of the tool, or? Yeah,
so explainability, I sort of hinted at pseudo explainability when changing the variables, but proper explainability in terms of Shapley values, for instance, that has not been integrated so far, but that is one of the features that we have in the books. So yeah.
So keep us posted when you've got explainability in it. I would like to show it, and maybe have a dedicated session on that, because that would be awesome, or something like a bite size, maybe five minutes or something. I would look forward to that a lot.
Yeah, of course, no problem.
Hey Ralph, you've got a question. Ask your question.
Yeah, thanks. Amazing presentation, David.
Thanks.
I'm just wondering, I mean, we are in the software industry. We do a lot of testing, regression testing, unit testing. We have to ensure that our software is reliable, is flexible, is working for the user. How do you test AI?
So testing in the sense whether our solution works with different data sets, or
testing, for example, how do you ensure that your model is not biased, for example, on gender, on location, the obvious problems that, for example, the AI from Microsoft faced when it went live on, I don't remember, was it on Twitter? I think they put something on Twitter, and the users trained the Microsoft AI to use swear words and so on. So that's a biased trained model. Yeah. So how do you ensure in your data scope that tomorrow and the day after tomorrow, your model is not reporting biased charts?
Yeah, I got you. So I think in our context, that might be a bit less of an issue, since we are focusing mostly on financial time series. And as such, as long as the prediction is close to the actual values, we should be fine. However, I'm not saying that unbiased results are not of importance. But in this context, time series prediction, we might not be as exposed to ethical concerns as, for example, in classification, what person might receive a credit or what person would not receive credits. But not to cheap out from your question, we cannot be 100% sure that if you feed biased data into the model, that you get unbiased results, of course. So it's an issue, but I think it's not as severe for the case of forecasting.
Bias in the terms of financial data could be bribery or fraudulental data coming into the system, and by that manipulating your forecasts. It's not only on gender or skin.
Yeah, you're perfectly correct, and I am on the same page. But I think I'm not sure whether incorporating a variable that would capture fraudulent activities in some sense would actually make sense to give us more information on time series the next day or the next week. So yeah, it's a problem. No, you're right. But as I said, I think it's less severe for forecasting.
Okay, great. Thank you.
Thanks for the question.
Okay, do we have more questions? Erdogan, you had plenty of questions. I'm sure you have another one. Feel free to unmute yourself, anyone, and ask the questions.
If there are no questions, I just had an idea. Getting back to Ralf, actually. This might also be a factor that we might look into using explainability of variable importance. And once you might see that the algorithm, your prediction, focuses too much on a variable that might be unethical, you could step in and take care of that. So having variable importance implemented is very worthwhile. Thanks for bringing your question up.
Yeah, and I think, I don't know what the output of the explainability is, but if the explainability is like, let's say JSON or XML or YAML, you could, if you find some values and ranges, this is where you would be able to use more QA-like tools to see if your values are in the right ranges. That could do the trick. If it's in plain English or German, then it would be a little bit more difficult to do that. So, hey, I've got another question from a guy you may know, Martin Otto. Do you plan to integrate this solution with Cloud Pak for Data or OpenScale?
So we've talked about that briefly. One possibility of integrating this service into Cloud Pak for Data might be via API requests. So that should be possible. We are not 100% sure how to make use of it with OpenScale. I think some models we are using are supported by OpenScale, but I'm not sure if 100% of the models we are using are supported by OpenScale. So we might look into that, but yeah, there's much stuff to do. So no final answer.
Artificial intelligence.
Data. Analytics.
User group.
AIDAUG.
Join AIDAUG today.